All right, Algebra 1, Factoring Polynomials, Part 1. So, we are moving on to factoring, which I like to call the second dirty F word of Algebra 1. The first one was FOIL, and the second one is factoring. So, I really like this meme, and I just want to talk about it real quick before I move on with the video, right here, this one. So let's take a look at it real quick. What if I told you you do algebra in school to train your brain not to use it in your future career? So that's for all those of you that are like, when am I ever going to use this? Well, maybe that's not the point. Maybe the point is learning how to structure the way you think to solve problems and think abstractly. And that's what we do when we think about using variables and when we think about these polynomials that we're looking at. We're thinking abstractly. And unfortunately, just because of the snow, we won't get to the examples until after spring break, but these polynomial equations are hugely helpful in the real world. There are actual things we can do with them out there in this real world they always talk about. So I'll be able to do that for you, all right? But we're training our brains. We're learning how to think. We're learning how to organize our thoughts. This video is going to be on factoring polynomials of the type x squared plus bx plus c. And we're looking at factoring also perfect square trinomials and the difference of squares binomials that we get. So factoring is like Jeopardy math. Let me show you what I mean. Okay, when we're doing factoring, we're taking a trinomial like the one you see here with the b and the c. Okay, x squared plus bx plus c. We are taking that and we're writing it as the factor of two binomials. That's what we're doing. In order to factor, you're going to take it and you're going to write it as the product of two binomials. So it's like FOIL but backwards. That's why I like to call it Jeopardy math. Not that we're actually going to play Jeopardy, and don't whine about that. We play plenty of cool things. But it's kind of like we're doing Jeopardy because in Jeopardy, they give you the answer, and you have to give your answer, you respond, I should say, in the form of a question. So in order to factor a trinomial like this one, what you have to do is find factors of C that have a sum of B. Those of you who got them in class would recognize this as your X puzzles, your sum and product puzzles. Factors of C that add up to B. Let's do a quick example on this page, and then we'll look at specifics. All right, so there's my example. X squared plus 5x plus 6. We're looking for factors of this number. Okay, we're looking for numbers that multiply factors of this number. So they multiply to give you 6 that have a sum of 5. Factors of 6 that have a sum of 5. So first you think about factors of 6. Well, 6 has two pairs of factors, 1 and 6 and 2 and 3. Well, 1 plus 6 is 7, 2 plus 3 is 5, 2 plus 3 are the numbers I'm looking for. Once you have those numbers to write your answer for a factored problem, to write your answer for this problem in the factored form, you're going to write two binomials. You know they both start with x. The reason you know they both start with x is that if you FOILed it, x times x is the only way to get x squared in one of these binomials, in one of these problems, I should say. Then you're going to take your two numbers that you found, 2 and 3. It's positive 2 and positive 3. And we just factored that trinomial. So we got our two binomials. Now, think it out, multiply it out in your mind. X times, oops, sorry about that. My error. Let's fix that. Okay. X times x is x squared. X times 3 is 3x. 2 times x is 2x. 3x and 2x makes 5x. And 2 times 3 is 6. So this does indeed give me x squared plus 5x plus 6. So let's you try some. Now, we have some ways that these problems can differ. Let's examine. Okay. So say that they're both positive. Both B and C are positive, just like the problem we just did. You're looking for pairs of factors of 15 that add up to 8. And so it's the same kind of problem we just did. X squared plus 8x plus 15, so pairs of factors of 15. Well, again, 15 only has two pairs of factors, 1 and 15, 3 and 5. The only one with a sum of 8 is 3 and 5. X plus 3, x plus 5. Multiply it out to check it, but remember your answer is indeed this right here. That's your answer. You try the next one. Okay, so What's the factored form of r squared plus 11r plus 24? Pause it and try it on your own. Well, we're looking for factors of 24 that add up to 11. Well, 24 has a lot of factors. So I need to either start at the beginning and be systematic, or I need to think logically. So 1 and 24, 2 and 12, this is great and all, but these numbers are bigger than the number 11. So it doesn't really make sense for me to be using these. Let's think about numbers that are a little bit closer together. How about 4 and 6? Well, that would add up to 10. So I'm close. I'm close. Okay, so it's not 4 and 6. How about 3 and 8? Ha, that's it, 11. So that means when I factor it, I have r plus 3 and r plus 8. Now, if you did it and you came up with r plus 8 times r plus 3, that is the same thing because of our good old commutative property of, in this case, multiplication. So either one of these would be fine. Okay, so let's try another scenario. Scenario, tomato, whatever. Okay, so in these, b will be negative. The sum number will be negative. The product number will be positive. Let's stop and think about that for just a minute. If the product is positive and the sum is negative, that means it must be the product of two what kind of numbers? That means both the numbers that we find for this particular product and sum must be negative. They must be negative because that's the only way you get a positive sum and a negative, positive product and a negative sum. So, x squared minus 11x plus 24. That's the problem we just did, except now we're dealing with a negative sum instead of a positive. So we know that our two numbers must both be negative, and here's your list of factors of 24. Here's your list of sums for those factors, and there again, just like we did for 3 and 8 positive, negative 3, negative 8 give you a sum of negative 11. Now look at the factored form. It's x minus 3 and x minus 8. And you can see here when they FOIL it out, it is indeed the correct answer. You try the next one. Pause it, try it on your own. Okay, but I'm going to look at it with you. So, or I look at it, I guess, if you restart, now I'll give you the answer. Factors of 8 that add up to negative 6. So 8 has factors 1 and 8 and 2 and 4. And 1 plus 8, I should say negative 1, negative 8, and negative 2, negative 4. Now, if you think about it there, guys, it really doesn't matter if you think about positive or negative numbers right now, as long as you make sure in your answer that they're both negative. Because the sum of two positives and the sum of two negatives of the same size, absolute value-wise, is still going to be the same number. It's just that the sum of the two negatives will be negative and the sum of the two positives will be positive. So, factors of 8 that add to negative 6 are negative 4 and negative 2. So y minus 4, y minus 2. Double checking it, mostly mentally. Y times y squared, we're good. Y times minus 2, minus 2y, minus 4y, total of minus 6y. Minus 4 times minus 2, positive 8. Sweet. Can we factor? So this one's different. B is different. It says, can we factor x squared minus x plus 2? Well, can you find factors of 2 with a sum of negative 1? I can't. The only factors we have of 2 would be negative 2 and negative 1, or positive 2 and positive 1. It's a prime number. 2 in itself are the only factors it has. So this one's impossible. So the answer there is no. In fact, the answer there is that polynomial, no, I can't factor it, but that polynomial is what we call prime, just like a prime number. It can only be broken down so much, and with polynomials, prime means cannot be factored. And that will happen from time to time. All right, another scenario. In fact, the last of the scenarios, whatever we're going to call it. So, x squared plus 2x minus 15. So now we're looking at ones where the product number is negative. If the product is negative, that means that one factor is positive and the other is negative. So, instead of looking for numbers that have a particular sum, we're kind of looking for numbers that have a particular difference. Let's think about this. We're looking for factors of negative 15 that have a sum of 2. But really, if we try to think of factors of positive 15 that have a difference of 2, it's the same thing. Let's look here. 1 and 15. Whoop, did not mean to write on that. Let's fix that. sorry. 1 and 15 does multiply to give me 15, and if you subtract, you get 14. If I think 1 and negative 15, there's your negative 14 sum. So that is something I just want you to think about, those of you who are getting fast at this. If you're not getting fast at this, then plan to write this stuff out for a little while, and that's okay. So let's look. Factors of negative 15, 1 and negative 15, negative 1 and 15. 3 and negative 5, negative 3 and 5. So in this case, the only one that adds up to a positive 2 is a minus 3 and a plus 5. You try these two. I want you to pause it and try them, and I will go ahead and write it out. So I'm going to do this my way, where I just talked about a minute ago, where I'm going to look for factors of 36, but I'm going to look for them to have a difference of 9. So let's list my factors of 36. 1 and 36, no, clearly not. 2 and 18, no, clearly not. 3 and 12, that's it, 3 and 12. And 12 minus 3, or 12 plus negative 3 is what would give me a 9. So that's my two numbers, 12 and negative 3. So instead of looking for factors of negative 36, I thought, well, how about factors of 36? But when I subtract, I get 9. Then I just have to remember to make sure my bigger number, in this case, that's the 12, is the positive, so that when I add these two, I get a positive 9. So we have n plus 12 and n minus 3. How about this one? Factors of negative 21 that add up to negative 4. Now, some of you might be getting super fast at this, which is awesome. I always thought factoring was fun. That's like the third dirty F word of Algebra 1 is fun. It's okay to admit that you're having fun with these problems. I think math is fun. I know I'm supposed to. I do it for a living. Anyway, factors of negative 21 add up to negative 4. Well, the only factors of 21 are 1 and 21 and 3 and 7. And there's the one with a difference of 4. Now, if I want the 4 to be a negative 4 when I add those two numbers, then my 7 has to be my negative, and my 3 has to be positive. Let's check it. C times C, C squared. 3C minus 7C comes out to negative 4C, and negative 7 times 3 comes out to negative 21. We did it. Oh, let me go back and check this one. N times n squared. Minus 3n plus 12n is 9n when you add the like terms. Multiply, you get negative 36 there. Okay. All right, you try these. I'm also going to try them, but instead of giving you the wait time here, I'm going to go ahead and actually pause it and write them out. So you pause it. No, you pause it. Try them first on your own. Don't be dishonest. Okay, I'd pretend that I could see you, but that would be creepy and a lie. So I won't pretend I can see you. You're just on the honor system. All right, here come your answers. And here you go. Let's go through them real quick. Okay, product is 12, sum is 7, 4 and 3. X plus 4, x plus 3. Remember, if you have x plus 3, then x plus 4, that's also fine. Factors of 42 that add to negative 13, negative 7, and negative 6. Factors of negative 40 that add to positive 3, positive 8, negative 5. This one was definitely different. Let's spend another couple seconds going over this one. So when you have a b squared here, it just means, think back to the classwork for multiplying binomials. When you have a b squared here, it means that the second term in each binomial has a b in it. And you can see that result in the ab term here and the b squared term here. So you're still looking for factors of 32 that add up to 12. It's just that you're going to tack a b onto your factors. So factors of 32 that add up to 12 were 8 and 4. So it's a plus 8b and a plus 4b. All right, the area of a rectangle, it was given trinomial. So that means that area would be like here. So an n squared minus 3n minus 28 is the area. I have that very hard to write that small with the stylus. Is the area of that rectangle. So I factored it. Factors of negative 28 that added to negative 3. Negative 7, positive 4. So when we say what are those dimensions, that would be the dimensions. That's what they're looking for there. Great, let's look at two kinds of special products. So this is going to be more about recognizing the numbers. You are still going to be able to use the other methods we learn in class, but I want you to remember here, and I want you to go and write this into your notes, please, that when we square a binomial like this, a plus b, the quantity squared, it's like multiplying it by itself. And when you do that, you get a special pattern. The front end is a perfect square, the back end is a perfect square, and the middle term is 2 times the square root of each of these other terms. Okay, let's look at that right here. X squared plus 8x plus 16. 16 is a perfect square. X plus 4, x plus 4, okay, are my two binomials. 4 times x doubled is what gives me this middle term right here. Look at this one. Square root of 9 is 3. The square root of 4 is 2. The square root of 4n squared is 2n. So when you see a perfect square, it's a pattern we want to try to recognize, we can use that. Let's look at a couple real quick. How about x squared plus 6x plus 9? 9 is a perfect square. That means this is x plus 3 times x plus 3. Remember to think about what happens when you get your outer and inner product. It's two of the exact same product. 2 3x's gives me 6x. Can you think of another one? How about that? X squared plus 4x plus 4. That's x plus 2 and x plus 2. Square root of 4 is 2. 2x times 2 gives us the 4x for the middle. And keep in mind that I could write each of these as x plus 3, the quantity squared, or x plus 2, the quantity squared, and that is still the same thing. So that is a product to look for. I won't be giving you any like this yet, not until we do the other factoring type, but still. Last one, the difference of squares binomials. This is really easy to recognize. For one thing, it's a binomial. That makes it totally different from any of the other ones we looked at because they were all trinomials. So you're looking for perfect square minus perfect square. So x squared minus 64, for example. And it's really easy to factor. You could think about it as finding factors of negative 64 that add up to 0 because there's no x term in the middle, and that's positive and negative 8, and you can see that right here. But to factor a difference of squares, it's actually a lot easier than that. What you're going to do is you're going to look at it and you're going to say, are they both perfect squares? Yes. Is it a difference? Yes. Take the square root of each one. It's x plus 3 and x minus 3. One's a plus, one's a minus. So we will practice with the special products in class. Now, one more thing. You noticed at the beginning of the video that all of our trinomials were x squared plus bx plus c. And that means that the value of the coefficient of x squared, which is often called a, in all of these problems was a 1. Those are markedly easier than ones that do not have a 1 there. And this, the ax squared plus bx plus c trinomials, where a does not equal 1, that will be covered in the next video. See you guys in class.